Okay, I hope you can all see that. Welcome to this terminology server Learnathon. My name is David Hancock. I'm a co-chair of INTEROPen, and I have the pleasure of introducing to you Dougal Flemming, CTO of Dedalus UK and Ireland, and Steve Harris is a senior standards architect at NHS England, who are going to talk to you about the terminology server here in the UK. So I hope you're all really looking forward to this. I certainly am. Just as a quick introduction to INTEROPen. INTEROPen are a not-for-profit organisation dedicated to the adoption of open interoperability standards in the UK. Now, as the adoption of open interoperability standards is a wicked problem, all those who face the problem must be part of the solution, which means that INTEROPen is made up of NHS England, also the trusts, the digital health networks, CCIO, CIO, and CNIO, standards organisations, and vendors. So you've got all the people together that are required to be able to help us drive adoption. After all, I think most of us realise that solving the interoperability problem is far more of a process and people problem than it is a technical problem. So a quick overview of the introduction. Sorry, a quick overview of the agenda. First of all, we're going to have some terminology foundations, sort of how to use the terminology server and why, and that's going to be given by Dougal. Then we have a deeper dive into SNOMED CT and how to use a terminology server with FHIR questionnaires, and that will be done by Steve Harris. You'll have a break at 11:20, so I hope you can all wait till then. We'll have a 10-minute break. We'll then have a demonstration with the terminology server and FHIR questionnaires, and then Dougal will do a wrap-up around some of the more detailed things around the terminology server, as you can say, sort of mapping, validation, binding, collaboration, and sharing. Then we will have 15 minutes to questions. I hope that's enough time. If you do have questions, please stick them in the chat. I'll make the note of them, and we will try and get through as many as we can in the time. So with that, I'd like to hand you over to Dougal to take you through the first part of this agenda.
So good morning. Hopefully you can see my screen. Does that come through okay?
Yes, that's come through, Dougal.
Lovely. Right. So to give you a bit of an introduction, and you'll have to, I guess, humour me and maybe tolerate me. I don't know anything. I don't know much, right? But if I send the obligatory new tech drone up into the air, I do know that there are some things that, even if I'm not a health economist, even if I'm not an expert, I do know there's some things in the system that don't look very good. So we have things costing more and more and more. We have the proportion of money we're spending on trying to fix health going up and up and up. And we have demand going up and up and up. And we have a shortage of people available or trained to solve this problem. So we will get to the thread of terminology in a minute. But I think it's pretty clear that there are some tough challenges facing the system as a whole. So it doesn't look at the moment like demand is showing any sign of reducing. It doesn't really look like more money on its own, or maybe at all, would be a feasible way of solving a problem of this kind of size. It doesn't seem like we could just train more people fast enough or work harder to solve the problem. So if we carry on with the same approach, it doesn't look all that hopeful, in my opinion. Right? I know nothing, and like I said, I'm not an expert, but I just think there are some pretty obvious facts, there's some pretty obvious things. The signs are are looking quite tough. So we have to kind of look around for another option, right? So you look at major inventions, possible transformations of what could solve this problem. And there's probably two on this diagram that have any hope, and the one in the middle is gunpowder. I'm not sure we really want to follow that route. But if we look towards the right-hand side, we have hopefully a figure you'll recognise as Mr. Babbage, who invented computers. Okay, so if we can't solve it with money, we can't solve it with people. We have to try and find a different way of enabling something else to help. So computers are brilliant, right? They are able to scale and amplify what we can do as humans, right? But one of the problems with scaling and amplifying things is that the scale and amplification of the good things is amazing, and the scale of the amplification of the bad things can be even more substantial. So we have to be really careful that when we're applying technology, we're applying computers to problems, that we actually get the right things that we want to amplified, and not the wrong things. So you'll all be familiar with the kind of, garbage in, garbage out. The problem with computers is it's not just garbage in, garbage out, and as we move further into AI and machine learning and things like that, you're also generating garbage and you're multiplying garbage. So it's not just a bit of garbage in and a bit of garbage out. It's a little bit of garbage in and a hell of a lot of garbage out. So I think in my experience at the moment, when you look at what people are presenting and what people are looking at solutions, they put a bit of AI on every single slide. So I've put a bit of AI on this slide for you. I asked, I can't even remember which image generator it was to give me an ostrich with the head in the sand. And to me, I think this symbolizes, I guess, or represents what I think people are doing at trying to address the problem, starting from the wrong place. So you can throw computers at a problem, and you can throw massive, clever AI algorithms, you can throw large language models at things, you can do all sorts of stuff. But you really are avoiding the obvious if you don't recognize this, right? So if you want to be able to enable an amplification of something good, you want to be able to let computers help, let computers support solving the problem that we kind of established, people and money can't solve. You have to fix the fundamental piece around, well, you have to stop the garbage, or you have to create quality information to allow you to amplify something good. So again, I don't know much, and one of the nice things about what I'm presenting here is I'm not presenting a whole solution. What I'm trying to do is present some options that might help. So I don't know much, but I do know a few things, right? So I know that the better the information you have, the better the help you're going to get. And I know that the less information you lose every time you exchange that information with somebody, the better the help you're going to get. I know that the more detail and specifics you've got, the better the help you're going to get. I also know that the closer to the point in time of collection, the higher your chances are of getting all the information you need and getting high quality information. So that means it's not something where you can solve this problem by just doing what you're doing and then looking back 6 months later and trying to work out what it meant and what it all means. You really have to try and make sure that you're getting as close as possible to the individual who's either part of the treatment or is being treated, or you're the person who's collecting that information with the clinical knowledge and understanding of what's going on. I also know that the more information you start with, and the more time and chance you have to add to it. And one of my personal frustrations in my interactions with healthcare services is that I would say often you spend 2/3, 3/4 of the time of an interaction that should be a high quality interaction, really just repeating yourself, because the starting point of the person or the engagement you have with somebody, the starting point is a blank sheet of paper because they haven't got high quality information as input, so they start again collecting it. And I also know that the more meaning you have in the data you've got, the better chance that a computer can do something useful with it. So, like I said, I don't think any of these things are particularly controversial. I think they're blindingly obvious, right? But I think one of the challenges is that there's a whole bunch of blindingly obvious things that are not getting enough energy and effort to address. So we just need, a really good way of modeling and describing things, some collaborations to improve the model. We need to share information. We need to build on that information, and we need to share it forward for the next person. We need kind of enough people to agree that it's a good idea and to work together on it. We've got Babbage, we've got Moore's law. Computers will get more powerful all the time. Jobs are good and jobs done. We're all there. But I guess maybe it's not as simple as that. Maybe we're not, right? So this is not to be a criticism of anything that's been done in the past. It's all foundations that build us to where we are. But SNOMED, which is I think the richest way of describing clinical information, started in 1965. It's not something that was invented very recently. It's been improved over time, but it's been around for a really long time. If you look at it, you try and get hold of it, you try and do something with it, you'll find that it's quite big and it's quite complicated, right? The document that you need to understand in order to even understand the release file that SNOMED produces, 282 pages. I think the editorial guidance is like 600 pages. This is complicated and difficult to get hold of. It's amazing, it's really powerful, and it's really comprehensive, but it isn't easy, right? And similar thing with DMD, although probably not to quite the same extent. But the reality is that in a lot of cases, it sits in the too hard bucket, right? The easy way of doing something, which is often what people are forced to take, doesn't involve doing things and describing things well. You also have the problem, and this is kind of related to the million concepts, that you try and help a clinician. You think, I'll give you amazing terminology. I'll give you the best possible way of describing things, the richest possible variants, and you put it in front of a clinician with the wrong interface, and you're not helping them, right? You're confusing them with complexity. So rather than by giving them a rich, expressive way of describing something to make it easier for them, you've made it harder for them because they can't find them. They could describe something very accurately, very specifically, but you've put so much noise around it and you've put such a bad interface around it that you make it even harder for them to find something, and they just resort to, I guess, the simple option, which is not to page through thousands of pages to try and find exactly the thing they're looking for. You just end up with free text or handwriting or something. Sits in the too hard bucket. So I don't know much, but I do think it's possible to improve that picture. And I also think probably we've spent long enough talking about things that I don't know anything about, and we should get on with talking about terminology services. So, basic building blocks for terminology services. I've kind of, these are conceptual things rather than pure FHIR things. But in essence, there's three basic building blocks, or maybe four, right? There's a code system, which is basically a set of concepts. And by concept, think of, coded value, coded element, or just a thing, right? So a code system is a set of things coherently with coherent meaning. So code system, as an example, might be ICD-10, might be DMD, might be SNOMED, it might be HPO, anything like that. It's everything, or a whole set of concepts with a coherent meaning, all described. Then you've got a value set or a subset of concepts for use in a particular context. So that might be I don't know, a set of codes to describe, I think we'll stick with diabetes, maybe a set of codes to describe diabetes might be a value set. It also might be, the set of codes relating to how you describe diagnoses. But essentially, it's a subset of things from a code system or from more than one code system that are for use in a particular context. And then another building block we've got is the concept map. So in the best possible view of the world, right, everybody would start off describing things using the same language, the same code system, and you wouldn't really need a concept map, right? But in the reality is that that isn't the situation you're in. And also, you're not always in a situation where there's one code system to rule them all. Sometimes there's different ones that suit different things or suit different use cases. So the concept map allows you to relate, concepts described in one code system or in one value set to concepts described in another. And they're essentially the basic building blocks of the terminology model. And one of the key things about the terminology model or the FHIR terminology model is that it's terminology agnostic, right? So when we looked at this, SNOMED's a custom file with a really difficult specification to understand. DMD is not quite as complicated, but it's still a 40-page spec and a completely different way of describing the concepts. The FHIR terminology takes those different terminologies and uses the same model to describe them. So the same API, the same model, the same way of interacting things applies to your terminology, whether it's SNOMED, whether it's DMD, whether it's ICD-10, whether it's even ODS data like organization data. It's the same thing. It's the same model, and it makes it much, much easier for people building systems or people building interfaces to learn one way of doing something and then apply it to lots of different use cases and lots of different terminologies. So I'm conscious that we've got a variety of people on the call, and we've also got a variety of kind of views on how data should be described, looked after, exchanged. And maybe when you hear FHIR terminology, you might put a little bit of a hand up and go, I use something better than FHIR. I don't like FHIR. I have a use case that FHIR doesn't work for. But it really doesn't matter, right? In the quote from my teenage children that they say to me all the time whenever I try and complain about something, nobody cares, right? Nobody cares, right? It doesn't matter that it's FHIR. What it matters is there is a really good model for describing terminology that has a kind of a carefully thought out, rich REST API that happens to be FHIR to interact with it, and everybody uses it. It makes life easier. So it doesn't matter if you're in the openEHR world or the OMOP world or the FHIR world. It's a REST API with a well-described standard way of interacting with terminology. The FHIR terminology APIs are used with openEHR tools. They're used with OMOP tools. They're used by people doing lots of different things that have nothing to do with FHIR. And this isn't, it's not a slippery slope that is the gateway drug to getting everybody into the FHIR ecosystem. It really isn't. It's just a REST API that provides terminology in an easy to use, easy to consume way and well modeled. So basically, FHIR is a great thing. I'm not saying FHIR is not an answer to lots of problems, but you don't have to turn your back on a FHIR terminology server just because you're not in the FHIR ecosystem, because people use it across lots of different ecosystems, and it isn't really opinionated or anything about that. It's just a convenient REST API to do something that makes it easier than taking massive files and learning massive file specifications. So get on to sort of the key operations that it enables. So we've got the three building blocks we talked about, and I think the operations that are most used are expanding a value set. So that means basically take a value set and tell me what's in it, or tell me what's in it filtered by a particular criteria. So that's the thing that enables you to solve this problem, right? That's the problem on the left here is a very big value set with no way of interacting with it. It's a way of getting from that to something that is usable and easier than writing free text to describe something. Validate code is essentially mainly used for interoperability use cases where you want to say, I'm expecting to see this kind of thing in this field, right? I want to check that I am seeing that. So am I being given garbage or am I being given good data? Value set validate code allows you to do that. You pass it in the thing you're getting and the context, and it will tell you whether or not what you're getting is part of your specification or not. Next one that gets used a lot is translate, and as I've kind of alluded to, not everybody uses the same code system. Not everybody needs to use the same system. Can use the same code system. Translate is the operation that allows you to normalize data or standardize data and move from one terminology or value set to another. Code system validate code is pretty similar to the value set validate code. It just works on the whole code system rather than a subset of it. Subsumes is useful for understanding whether something is something else. So we'll look in a few minutes at some examples around diabetes, but it's a way of testing whether or not something is a type of something else. So if you've got a very granular code for something and you're interested in looking at a high level, it's a way of saying, type 2 diabetes is diabetes, right? It's that kind of test. So it allows you to see whether you're looking at a more specific term or a high level term, and it also allows you to group and aggregate information. And lookup is an operation that kind of brings you back for a specific code all the details about that code. So we've got some basic key operations which are turn the complexity of a complex code system into something that is a single API call away. To get a little bit more advanced, we also have structure definitions, which are really a way of just defining the structure, the data elements, and the bindings and rules around a specification for data. So, this is how you say, there are these fields I'm expecting, and this field should come from this value set of values. And you can use that structure definition to support another REST operation to allow you to validate that the whole of the resource that you're exchanging is valid according to all those rules. So, example use cases of those operations, we probably break them down into a few different categories. So we've got kind of authoring, maintenance, and distribution. So this is your way of sort of establishing your standards and sharing them with other people. So that might be national standards like SNOMED or DMD, or it might also be local standards where you've got particular systems or particular organizations that need to have their own codes, but they want them to be consistently used and they want them to be consistently shared, and they want them to be able to be related to the national or the regionally relevant content. So it enables, the terminology service enables you to have a single source of truth for these things, to maintain that single source of truth, and also it do that with the least work possible. And what I mean by least work possible is that if we kind of go back a few years and probably even today, what happens in the system as a whole is that there are lots and lots of people repeating the same thing, doing the same thing in the same way in lots of different places just because they're in a different place and they don't have a way of sharing the thing that they're doing. So this is a way of basically enabling you to do something once and share it with all the other people that are trying to do the same thing. And that has the potential to accelerate what's possible, because there's a limited number of people available and there's a limited set of skills available. So by sharing the effort and sharing the artifacts that are useful, we get more artifacts and more useful things. The next kind of category is around interoperability. So this is kind of where we come into those validate type operations. So it allows you to establish that the information that you're sharing or moving or receiving or looking at is valid according to the definitions that have been specified and compliant with the rules that have been laid out. Next one, which we're probably not going to go into too much detail around today, but is around analytics. So if you want to get the most use out of the well-described data you've got, you have to understand the hierarchies, the relationships between the data you've got and other things, and understand the meaning of that information. And the terminology server, by enabling you to do subsumption testing and things like that, and also to do navigation of hierarchies reasonably easily, it allows you to do things like feature extraction from your data. It allows you to do cohort aggregation. It allows you to interpret what you've got and group it in an easy way, leveraging the terminology itself rather than having to kind of rebuild into your analytics and understanding of that terminology. So it can also be used in analytics to do, translations as on ingestion or even on processing in your analysis pipeline. The information modeling and specification development, again, is another key aspect and probably comes a little bit before the validation. But that's where you're establishing standards, you're establishing the model that you're expecting for different contexts, and you're able to, rather than describe it in a Word document or a PDF that somebody has to read and interpret, it allows you to describe it in a computable way. So it allows you to take the definition of all the rules and all the things that you're trying to enforce about the information you're looking for, and make that computable. And the final piece on this use case is around smart data entry and performant runtime use. So for this, we're coming back to that kind of obvious question of the best chance to get the best information is as close as possible to the point in time of collection. So the terminology server APIs allow you to, right at the point of interaction, provide information and provide searching capability that turns something from, one of 4,000 codes or spread across lots of pages to type ahead search to retrieve the thing that I'm looking for based on the context and maybe the surrounding information that I've already collected about things. So it's an encounter. So it's really about turning SNOMED from being something, or complex terminology from being something that is in the too hard bucket to the it makes it easier bucket. And that is something that Steve is going to give you a lot more detail on in the second part of this Learnathon. So a few things about the NHS terminology service. Where do you access it? So there's a link here, ontology.nhs.uk, quite snappy, quite easy, and that'll take you to a landing page where you can go and explore. In terms of what's in it at the moment, and this is all about starting from a better place than you would if you were starting from scratch. So you go there and you'll already find the nationally relevant code systems that are applicable to what you're trying to do. And if you find things that are missing, then request them and we'll try our best to get them in. But it includes already SNOMED, DMD, ICD-10, NICIP, OBCS, UCUM, HRG, HPO, EVA, and ODS, or we'll talk about that maybe a little later. And all of those things are updated, within hours the new versions being released. So you can always go there and get the latest version of these things and the answer to the question you've got on your API against the latest version of the terminology. If you're a user, so you're a human, and I'll show you this in a minute, it's self-service. You don't need to go through a minefield or over any barbed wire to get access. You just go in, you log in, self-register, and you get access. As long as you accept the terms and conditions, you get access to the tools and the functionality that I'm going to be showing you later on today. If you're a system and you want access, there's a slightly different process. So there's a form to request access for system account. But if you want to explore it, you want to look at it from a user perspective, then it's all self-service. So probably enough talking and too many slides. And just to prepare the ground a little bit for Steve's presentation coming next, wanted to take a simple example and show you how the tools might help you to access that. So if we take an example that says we're looking for a way of describing different types of diabetes. So maybe it's for a field on a form, and that's something Steve will cover, or maybe it's to try and analyze some data that you've got to understand which patients or which bits of data you've got relate to somebody who's got diabetes. So I'm going to just switch over to another window. And hopefully you can just shake that up about right. So I'm just going to show you on one of the tools. So we talked about self-service. In fact, the NHS one has a few more options, but this just lets you come in and access the tool for browsing and exploring the content. I'm just going to log in with my Google account, and it's OpenID Connect integrated, so you should be straight in once you've accepted the terms and conditions. And we're instantly taken to a screen where you can browse different code systems. So you can filter the code systems here, and you can browse value sets or ref sets in that content. And you can also start searching for terms. So in this example, we were looking for diabetes. So if we look for diabetes, you can see that we can have a look at diabetes, and I don't know about you, but it's a little bit easier to understand SNOMED when you look at it like this than it is when you look at a kind of a half gig or whatever file that is full of lots of files that you need to first interpret before you can do something. So here we look at diabetes, and you can see diabetes has a bunch of child concepts that are more specific. You can also, maybe if we just click on something here, I don't know what Stimler syndrome is, right? But it's a child of diabetes. And if I look down, hopefully you can see the richness of the information that is provided with that concept. So this is just this is a concept code for SNOMED. Just by assigning some information to that code, I get all these relationships. I get all this information that is built into that single code. So you don't necessarily need to know that when you're using it. You just need to know that you're assigning a piece of information to the right patient in the right context. But when you're doing things in terms of analysis, or even you're trying to do a user interface where, because somebody's selected one thing, they intelligently get directed to another set of things, or you're trying to do some decision support, hopefully you can see that the richness of the modeling of that concept gives you a huge amount of power that just the term Stimler syndrome doesn't. So you're by recording information with this richness, you're unlocking the potential of doing much more with it. So if we go back to our diabetes mellitus I'll draw your attention to a couple of things. You'll see here that a child of diabetes mellitus is diabetes mellitus in remission. So you don't have to be, you have to look at these hierarchies, and you have to use them intelligently. But one of the capabilities that comes with the terminology server, that makes it more usable is a query language called ECL. So that's expression constraint language. So expression constraint language allows you to basically write queries in a simple way against the SNOMED hierarchy. ECL at the moment is just a SNOMED thing, but there is a new query language that is emerging called VCL, which is a value set constraint language. And that value set constraint language works across any terminology. And even currently, even without ECL, you can still use logical expressions in your FHIR value set composition to achieve some of the same things. So go to our ECL builder. Let's just stop cheating. So this allows me to build queries that say that turn into expressions that turn into essentially value set definitions that I can then use for other things. So if we go back to diabetes mellitus, you can see that there's one code for diabetes mellitus, but I can also do a descendants or self query on diabetes mellitus and see all the children of diabetes mellitus in hierarchies. These are all the more detailed concepts that are subsumed by diabetes mellitus. Another thing I can do is I can say this will only give me currently active concepts that match diabetes mellitus or the children of diabetes mellitus. But what I can also do is I can say, well, don't just tell me about the current ones. I want to know all the codes that have ever been related to those codes that we're talking about. So this now, and hopefully we'll be able to find one down here that's crossed out. Nothing on the list, but essentially this will give you all the inactive codes as well as the active codes, and that can be useful when you're doing analysis on data that may have been collected some time ago, because it allows you to cast your net not just to the current active things that match the constraint, but also things that would have matched that constraint but have now been replaced by better or non-duplicate concepts. So just go back to the current ones, and I think when we looked at the hierarchy, you also saw that there was some children of diabetes mellitus that were in remission. So what we can do here is we can exclude those from our list. So we can have diabetes in remission, and I can exclude descendants or self of that, and you'll see the numbers gone down slightly because we're building our expression up that says all of these minus these. We might also add another constraint to say, we're not interested in this gestational diabetes because we're only interested in people that have it on an ongoing basis. So we say any of descendants or self. So now we've got an expression that has 127 concepts in, and the key thing to mention here, I guess, is that by expressing this value set definition using a query language, we have something that is more robust to changes, more robust to movements in the terminology. Because even if a new version of SNOMED comes out, and there's one every month or so, the criteria that I'm defining this value set by are very likely to still apply even to a newer version, and they're likely to apply to an older version. It's not, they still need checking, but it's not like I've got to maintain a long list of codes and then review every single code every single time, and every single code that's been introduced every single time. I've really just got to review, is my expression still valid against any of the structural changes that have happened in uh, in in um, in the SNOMED terminology. So this is a tool that allows you to explore the terminology. Hopefully, it's makes it a bit easier to understand, makes it a bit easier than reading the documentation in its entirety. This tool is just something that it's a simple web app really that's sitting on top of the terminology server API. So it's not doing something cheating under the hood, looking at the back end. If you trace the requests on the tool, all you'll see is REST API queries going to the back end to ask questions. This is just a rendering of the result. And just to lay a little bit of groundwork for Steve, one of the things that you can do is you can say, well, copy the ECL query, which is a SNOMED thing, but I can also do copy the value set. And copy the value set basically takes this expression and gives me the FHIR value set definition, well, description of that of this expression. So when we were talking about the sort of expand operation, this allows me to come into an API tool. So let's just make sure I've got a token that's valid. I can come in and I can put that URL that I've just copied from that interface, and I can pass it into an API call on the server. So you'll see this is now 127 concepts that match diabetes. So I've gone from a kind of a fairly easy way to explore things to a button to copy that into a value set to an API call that took 91 milliseconds to respond to. And hopefully, if I'm not setting Steve up for too much trouble, he'll show you how you can take advantage of this kind of thing in building better user interfaces, better forms. I would also say that what you're seeing here is a cut down version of what you can retrieve from the API. So I can pass additional parameters to this API and say, give me back all the properties. And we might have to come back to that one. You can include designations, so you can see all the different synonyms, all the different descriptions. I think I just have the API parameter wrong, but property will allow you to specify which properties you want to also return. So this will give you all the relationship information. But the default is to give you back a lightweight response to support the minimum amount of information required from a network traffic perspective to retrieve the information that you need and support somebody to find the code they're looking for. And when we were looking at one of the user interface problems, we also have the ability to specify filter criteria. So we can apply a filter criteria. So this is kind of thing you might use in a type ahead search and see there's only three concepts that match a filter of Brit, and Brit is not this is probably a bad example because it's showing starts with, but this is essentially a search engine on the terms. So a term I put in here is something that gets evaluated against all the concepts that match the value set definition, and also all the synonyms that match that for those concepts. So it's basically a way of turning that list of 4,000 concepts we saw for hypertension or hyper into something that is a user can just do type ahead search on something, and the list of possible options narrows down to something usable. And hopefully with a few keystrokes you get to a small list that it makes it easy for somebody to collect information. So I think that hopefully gives you a little bit of an introduction to the basics and a little bit of a introduction to some of the tools. I think probably timing wise, we're coming up on when I need to hand over, and we'll pick up on some more of the operations and some more of the concepts in the third session that comes at 12, I think. So I can hand back to David at that point.
Yeah, thanks a lot. That's really good, Dougal. I hope people found that useful. Well, if we've got a little bit of time to fill, we have already got some questions in the chat, which I think would be useful to go through now. And there's one from Jonathan Telfer, to describe the differences, overlap, and use cases, etc., of the terminology server versus the SNOMED CT browser. So, yeah, what are the key things there?
What are the key differences? I think, well, one key difference is that that Shrimp, the tool that I was showing, allows you to go from exploring SNOMED to things that enable you to use it in the APIs against the terminology server. So the standard SNOMED browser will allow you to explore the content, but doesn't take you through to that next step. I think other differences, there are well, preferences, I guess. I personally find the way that Shrimp shows and allows you to explore the hierarchy and allows you to build up the ECL expressions, I find that makes it more accessible, more useful. But there are probably still use cases where the SNOMED browser may be more appropriate. The other advantage, I guess, I would give is that people in SNOMED world care about SNOMED. People in Loink world care about Loink. People in HPO world care about HPO. Having a standard way of exploring terminologies, regardless of where they come from, is quite a lot more powerful than having a whole bunch of bespoke viewers to view one part of the picture. But I don't know. I've noticed a few, proper experts on the call who might want to come in on that question and give a better answer. I can see Pete has already popped probably a better answer in. I put my dunce's cap back on and say, I'm here to help, but there are plenty of experts around who can also give better help in some cases.
Yeah.
Would you like me to come in there, or would you like me to leave you alone?
Yeah, yes, please, Pete, if you can.
I think the thing with the browser is that the browser's fundamental reason for being is looking at individual concepts. It does some other stuff bolted on in the background, but it's there to look at the details of an individual concept. When we look at things like Shrimp and the Shrimp browser, it's designed from a point of view of doing more than that. It is easier to do things like filter by value set. It's got much better visualization of looking at things beyond an individual concept. So if you search in the Shrimp browser for the values contained in my set, it gives you a lovely mind map view, and the things that are in your set are in green, and the things that aren't in your set are in black and white. So really, the browser has one reason for being, whereas the Onto server has a broad set of reasons for being, and it gives us the opportunity to build different interfaces on the data. So you've got Shrimp and Snapper and other things at the moment, but the Onto server is an extensible solution for doing things with terminologies and classifications, whereas the browser is a very limited solution for looking at details of individual things.
Thanks a lot, Pete. Yeah, we've got time for some more. The next one, not sure if we'll be able to answer this here. We might have to take this away, but if from Thomas, where does clinical liability / responsibility lie? Clinical users at either end may be unaware of what happens in between. Is that sort of a general clinical status?
The simple answer is that I think it lies at the system that is presenting something to the user. So it still sits at the system that's actually collecting the information responsibility. I don't think work any other way, but maybe we can pick that up in more detail and separately. Just conscious of time, and there's probably some down here that are quick answers. So Alex's question, when you're copying the value set, are you only copying the terms at the point it's authored, or are you copying the criteria? You're copying the criteria. That's really part of the power of it. You're copying the expression that defines it, not a list of codes. You can create value sets that are just lists of codes, but what I showed you, you're copying the logical criteria and you're executing that criteria against the server to give you the answer on the server at any point in time. You ask that question, and you can ask that question against multiple versions of SNOMED, and you can keep that expression over time. So it isn't hard coding the terms, it's the expression. And is Paul's question about, is it intended to be used real time? Yes, absolutely, it's intended to be used real time. John's question about exporting the ECL generator component. I think the ECL generator component, I don't know whether you mean the ECL that is created or whether it's more deep than that. But I don't know if you spotted, but there was an ECL copy button as well as a value set copy button. So you can certainly take that expression and use it elsewhere. And definitely kind of handcrafting ECL statements is for the experts. I would certainly, tweak them maybe, but I think having a tool that helps you to build them step by step is useful. I didn't really show you, but you can also write them by hand and do a free text ECL expression in the interface I showed you. But yeah, I think we can hopefully help you with what you're doing with the FHIR validation tools, and certainly you're able to validate the ECL statements against the server and validate the contents of any ECL query results against data using the APIs in the server.
Dougal, I answered the question below. The value sets that you presented, the URIs, they don't actually work with HL7 validation at the moment. But the ECLs do, but you need to create a FHIR value set to use them, if you understand. So okay. A traditional FHIR value set, which uses an ECL, will work, but that URI won't work with HL7 validation, but that's probably something we can investigate.
So I think Onto server, which is the solution that is used, is officially supported as a terminology server to use with the official FHIR validator.
No, it's a different concept. We're talking different concepts. We use the Onto server with FHIR validation. It's the two separate concepts. So when you say here's a resource in FHIR, we use FHIR validation. FHIR validation uses an ontology server. It's two separate things. They're not the same.
That they are two separate things, but I think they can work coherently.
If somebody wants to know how to do it, we have done it in NHS England, and we use it for publishing the simplifier assets. So all of UK core is tested using HL7 FHIR validation, and as part of that, we are linked to the NHS England ontology service. So we can explain it if somebody wants to know in detail.
Yeah, thanks. Probably worth taking that. Thanks for getting into some detail there. What else? Just very quick. Is there any others you can quickly pick up? Because I think it could be good just a few minutes. So we can
Eleanor's question about
more time.
Yeah, Eleanor's question about simplifier. So simplifier generates FHIR packages, and FHIR packages can basically contain the terminology assets that relate to a FHIR profile, and those packages can be imported into the terminology server and should be imported into the terminology server to allow you to basically validate against your profiles that you're defining in simplifier. So that simplifier is part of the tool chain that allows you to maintain profiles and IGs to support the use of terminology, and the terminology server will take the outputs of that, and in some cases can produce the inputs for that.
And Dougal, do you want to tackle Richard's question?
So, um, so Richard's question is about how hierarchical code systems, I think, are loaded in different ways in different terminology servers. So FHIR has attempted has provided a mechanism where people can register URLs for terminologies, and as part of that registration, they can also register the structure and definition of the use of that terminology in the terminology server. So when we looked at that view of the concept with lots of detail, the detail below was based on properties and relationships that are defined in the FHIR standard of how you represent SNOMED. So the same thing, is true of any code system. You can define how a code system should be represented, and the structure, so that it's consistent wherever somebody obeys that route. So it should be something that is manageable, but it is obviously something that requires people to follow a process to register and define something, and then consistently use it. That maybe not in all cases is followed, but I think there's a process that supports making that consistent. And I would also say, I know you're in the same situation as probably a lot of people on this call, is that you work in potentially different markets that are not just the UK, and that the nice thing about this is that you can just plug in a different version of ICD-10 from a different country with a different linguistic variant, or even a multilingual version, and your system can work exactly the same. It just points out the local flavor of a terminology, be it SNOMED or LOINC or whatever.
Okay, thanks for that. I hope that's explained it well enough for you, Richard. Should we pass over now to Steve to start his section? Yeah, over to you.
Sorry, for some reason you seem to have muted me there. Let me share my desktop. Can everyone see my desktop?
Yeah, we can.
Yeah, thanks, Pete. Right, okay. So I'm going to divide this into kind of two parts and lead into the questions afterwards. The first chunk is going to be mainly about what is FHIR Questionnaire? What does it look like inside? How is it structured? How does it work? And then the second part, we will create some questionnaires. We'll look at some pre-existing questionnaires with a particular accent on how FHIR Questionnaire works really nicely with ontology servers. So if we start off. So who am I? I'm new group, 18 months in, led by Nicholas Suterbridge in the Transformation Directorate, looking at logical models and record standards for care. So the notion is that you want to be able to get definitions into the care record so that your FHIR APIs can find that data and bring it out in the way it actually means, rather than sort of, I'm going to have to squint a bit and map this across, and it doesn't exactly mean that, and I hope it works at the other end. If you can get the data definitions in, then you can get out the data that you're looking for. So I've been a long time contributor to ISO, firstly for SC32WG2, which is the ISO IEC group that looks after metadata standards for data models and for data elements. So one of our standards is ISO 11179, which some of you might have heard of, which is an international standard for talking about data elements. Data elements being the kinds of things you find in the NHS Data Dictionary. I also edit a couple of standards myself. In particular, there's this standard here, 19763 Part 13. Apologies, ISO terminology is very, very opaque. Part 13 is a model for form design. So we established, I think 2015, 2016, we described what it is to be a form in terms of a model that you could register form designs with, so that you could communicate and standardize proposed standards for form designs. I also look after some XML and JSON schemas in there too. I am currently leading the UK FHIR Logical Models group. So if people are interested in logical models, please hit me up and I'll add you to the distribution list. We have our first meeting on the 4th of June, which is just mainly just talking about governance and remit for the group. Previously, I worked at the University of Oxford for 20 years, not as some kind of jumper with patches on the elbow wearing academic. I was working on practical semantic interoperability, mainly with clinical trials and clinical data. DevOps for the clinical data warehouse that OUH runs, which is I guess the first secure data environment. You've seen SDEs appear across the country now. A lot of the things that led to the development of the SDEs came out of the OUH clinical data warehouse. I handled DevOps, also grabbed the data out as well. So kind of the full life cycle of how do you define data and then how do you get that out and use it at the end to satisfy data queries. I ran the bioinformatics lab, the Oxford Molecular Diagnostics Centre lab, IT for the lab, excuse me, and had a few bioinformaticians to do with 100K programs and logical modelling around there. So forms have been with us for a very, very long time, particularly if you include tabular representation of data as being a form, then this is a data table from 5000 BC in, I think it's in cuneiform. Really, really old concepts. So old that the Germans even have a phrase, a saying about forms, from cradle to the grave, forms, which I find quite amusing. So the Oxford English Dictionary defines a form as a printed document with blank spaces for information to be inserted, and suggests an application form as being an example of this. The great thing about forms is that you can use them as part of a business process. So if you have a business process, you want to get from A to B, then you can include instructions on how to do part of that process with the bits of data that you need to continue the process on your form. So the idea of legal documents, template legal documents, is pretty obvious. Census data in China, the Romans were doing legal stuff with it. But forms really, really took off, I guess, with the evolution of the printing press, and burgeoning bureaucracy certainly used those things. And so the idea that you'd have a form to do this and a form to do that, a way of ensuring you gather data from the citizen that was necessary. You added data as part of the little boxes that have for official use only, which is where you add the data as part of the process. The process is your form. There's plenty of, there's a lovely link here that talks about the history of forms, which is really cool. And so forms encode expertise and aid the creation of complete records. So I guess the next revolution in forms beyond the printing press is when you actually get to have electronic forms. So with a printing press, yes, you can print some paper, and then the definition of the form and the questions, the answers all stay together. But there's only so much paper in the world, isn't there? Whereas there are any number of electrons. So you don't need a physical medium or real world storage. Answers can be typed for automatic processing, regular expressions. Interesting. You can start enforcing better data quality constraints. So with a paper form, you can scribble something in a box. But with an electronic form, you can say, no, you can't do that. I'm expecting a number here. And that's really cool. Predefined answer lists can be longer. So you've only got a limited amount of space on a letter size or A4 piece of paper, but your form in electronic format is virtual. It has a virtual amount of space. You can expand or contract it to add various pieces to it, and you can use the user interface of the form to excuse me if you can hear the dog in the background. You can expand the structure of, as was mentioned in one of the comments, you can expand the structure so that instead of just simply having a flat list of terms, it is at least in principle possible for you to explore a tree And for you then to present the knowledge model of something like SNOMED CT to the user. I don't have any examples of that on hand, I hasten to add, but it's certainly possible for you to do that kind of thing. So you can test and require for completion. No, you can't submit this form yet. You haven't filled in that piece of information. And that helps you with your business process down the line. So if you've got a business process that needs a piece of data in computable form, you put it on a form at the point at which that data becomes available, and then you can satisfy your business process and things move smoothly through. One of the problems with electronic forms is quite interesting, actually. It splits the question from the answer. So you look around the ways that we do electronic forms, and what happens is you end up with, particularly with HTML forms, is you end up with the questions on the definition of the form, and then you create a datagram of some kind that has the data that with the form. And because people, computer scientists, are obsessed with space requirements, they tend to leave the definition behind and say it's over there. You can find out what this bit of data means over there, or they substitute names for the attributes that don't necessarily bear a relationship to the form itself. They're kind of a mapping, if you will. And that's an interesting thing, because you can lose stuff in the mapping. And particularly if you're moving into relational, where question order, attribute order in a proper relational table should not mean anything, because the key, the whole key, and nothing but the key, all of those things are dependent. Whereas in a form, and when you're part of a business process, and particularly where you're guiding someone to do a task, then questions have lots of dependencies on each other. A lovely example that really brought this home to us about 15 years ago. We were working with the OSPAC longitudinal study of parents and children. It's a Bristol-based study that followed kids from, well, still following them essentially from before they were born. A whole bunch of mums to be were screened. They followed the ones who had children, and then they did loads of questionnaires about these kids. There's one questionnaire which was about the mother's attitude to father's family behavior. And there were interleaved questions about things like, does your partner smoke? And then there was another question following it, is, does this bother you? And you end up with this notion that you've got all of these questions that are the same question, but they're contextualized by the previous answer. And if you've done your mapping to your attribute names in poorly, then that kind of can get lost. So question order is really, really important, whereas in our databases, quite often we try to get the data shaped around in a way that the order of the attributes is no longer significant. And so it's important that you don't separate, or that you can readily access the definition of your questions when you look at the answers and try to understand what they mean. So what do I mean by a form? So a form is a tree of nested sections. So I've got this little, so this is a bit of UML. This is a UML class diagram. And this little box here with a line halfway in between it, and some emboldened letters at the top, and then some lists of other strings down below, is called a data class. And so I have a data class here called form. And a form has an attribute, one of these little bits of strings below, called a form name. So forms have form names. So yes, so we've got nested sections. So this structure here says that a form is made up of a bunch of sections, which also have names. You must have at least one section, but you can have lots and lots and lots of sections. And then sections themselves can contain other sections. This little pig's ear, Nicholas calls them. I'd never heard that before, but yes, this little self-reference that relates itself to itself allows you to have a section as trees. And then at the leaves of those, you have questions, and questions have text and they have instruction. They'll say, is the patient breathing? And there may be some instructions about on how to work out whether the patient is breathing or not, for instance, if it's to a non-clinical member of staff, for instance. Questions have responses, they have answers, but in the model of the form, what you're doing is you're defining the kind of field at which the answer will be put into. So you want to know things like data type. You want to know whether you need to answer this, whether it's an optional question or whether it's a mandated question. If it's a continuous quantity, if it's a count of something, or if it's a measurement of concentration, you will want some units of measure in there too. And then dependent on the kind of data that you're collecting, are you collecting some text? Are you picking from a list? Are you adding an attachment to the form? Are you loading up a Word document, for instance, or are you drawing some lines on a picture or a response? Then you want to, so this little arrow here with the open pointer means kind of. So this response field, you don't actually have response fields. It's in italic here, which means it's abstract, but you can have a text response field, which is kind of these fields. It has all of these attributes. It also has this extra attribute of regular expression. So for instance here, pick from list, well, it might be multi-select. You might be able to select several of the different answers legally as part of the form. And if you attach the file, then you would want a MIME type of that to know that, well, I want a Word document. I don't want an Excel spreadsheet as an answer to this question, for instance. So next slide. So this is the ISO forms model. And this talks, what this intends to do is it intends to allow you to go and find a form anywhere, any form, whether it be electronic, paper, cuneiform, and to represent what that form means as a registration in a database, so that you can go and find what that form means, so that if you had some data that was collected using the form, you could point at it and say, hey, I was collected using this form. You can understand the context of my collection a bit better if you go and read that. Or I have a data set. Maybe I have a clinical trials data set, for instance, or I have a CDS return. You can go back and point to various bits of the forms that were used to create it as part of the provenance of the data attribution, so that you really understand what the data means. It was always the thing, isn't it? If you get a data table in a database and you're trying to do some reverse engineering, you'd go and look at what the form meant to understand what the fields in your data table were. So very similar here. So we have a form design and some places where you can talk about the languages the form design is done in. Subforms can have forms as part of them. So there's subforms and superforms relationships. You could have a template that you use to create similar forms. So follow-up forms in clinical trials is a good example here, that they all have the same questions about the vital status. What is the patient alive? When did you last see them? It's for the sensor date for the clinical trial. But then there'll be some specific forms about the questions about the disease that the follow-up form is following. And then we have sections and questions, as you can see. There's this bit here in the middle about presentation elements, which allow you to put various bits of text all over the form, or pictures, or logos and the like. And question elements have responses, and then here are our list of kind of responses with some structure around those, and some stuff here that allows you to gate the answers, that gates the availability of questions and sections dependent on the answers of previous questions. So out of the box, it supports for multilingual forms, lots of presentation. You might not get precisely the right presentation. There's stuff where you can stick some CSS statements in here. Skip logic, form templating, subforms, all of that supported out of here. You can take a partial form, do a partial registration, record what a paper form is, maybe then relate a definition that's an electronic version of the paper form, and then suggest that people who turn up and find the paper form that's an electronic version over here, they might want to download and use. So on to the main part of this, FHIR Questionnaire. So FHIR Questionnaire talks about forms, but there's a lot less stuff going on there, isn't there? So what is it? Well, we've got this one data class here called questionnaire, and the questionnaire is effectively the same as this form design class at the top here. It's the metadata about the form. So it's the the way you'd find it, what its status is, who published it, so all of those kinds of bits of Dublin Core style metadata. And then it says a questionnaire is a sequence of items. You can just say a questionnaire exists and not say what the items are, because there's a 0 in this relationship here, but you can have as many items as you need to describe your form when you want to be detailed about it. And then there are a couple of other classes around here that says enable when. So enable when is about when you can answer this question. So this is about gating the availability of a question depending on a previous answer. Initial talks about what are the data that's filled in the form by default when you load it up. And answer options are where you've got codes and values that you select from when you do it. Oh, and items can contain other items. And I mean, if we go back to our definition of what a form should be and what all of the bits and pieces are in a form, then, well, there seems to be quite a bit missing there. So what FHIR Questionnaire does is, instead of listing all the different types of data classes that are necessary for you to make a form, it creates a bunch of rules on item. And so all of the kinds of things you want to say about item here are just listed as different attributes. So whether it repeats or not, whether it's required in the mandation, those things are all just listed. And then there are a set of rules to say what a valid item actually is, which is a bit opaque. It's quite nice in some ways, as if you are implementing FHIR Questionnaire, then this is a data structure you might put into a relational database, actually. And the idea of you having queries on that to find me all the sections in this form. Section must have these properties. That sounds like an SQL query, really. But it isn't very good for understanding what goes on. So here are some of the rules, and I won't go into these into great detail. The slides are available. There's all sorts of bits and pieces around the web that will help you with this. But for instance, it says that display items cannot have child items. So if I go back, I'm sorry, getting ahead of myself. Display items cannot have child items. So this relationship is not allowed if you've declared that your item is a kind here, type here. So questionnaire item type. If you say that it's a display item, then this relationship isn't valid to have on that display item record. Display items can't have data. They can't have codes. They can't repeat. They can't be read-only. They're just there. And so you see how this emerges. If you select an item type of a group, for instance, groups can't have data. Groups are sections. So sections don't have data as themselves. You can't have default values for them. And on. And it goes on further. So here are a bunch of things for question types too. It doesn't distinguish between the different types of questions, but there are a bunch of rules when you do select a kind of question for what kinds of things that you're able to say about that question in the item record. So, Steve, deconvolute all this. Tell me what this actually looks like. So I went through those rules. This is probably right, but there could well be mistakes in here, in some of the subtle bits and pieces. If I were to model FHIR Questionnaire in the same way as I modeled this by using data classes and data items, then here I have what FHIR Questionnaire looks like. So we have a container called a questionnaire, which is a collection of items. Items can be display items, they can be groups, and they can be questions. There's this notion here that some of these attributes apply to both groups and questions. So I've got this anonymous, that it doesn't exist, subclass that contains these attributes here, which allows me to separate them out from a display item, which is identified by having a code of display item, and it's a read-only thing. Enable when is a property of groups and of questions, so that gets associated here. And then groups, they just exist. Effectively, they have any of these attributes, but there's nothing more other than say the group has a type code of group. And then questions, there are two inheritance trees. There are two ways that properties get onto questions. So there's this notion of a simple question type in the rules where you've just got a max length and you've got either a text, so you can fill multiple lines of text in there. You've got booleans, decimals, set basic number, a URI that points to somewhere. If you've got a retrieved a result, FHIR resource, and that's the answer to your question. I mean, you may be saying something like, what's evidence for this particular observation that you've made? So you point to that resource there, you browse through and say, here's a laboratory observation that's evidence for my conclusion. Strings and integers. Then there are other bits and pieces, quantities. They're a special kind of stuff that have units of measure. And then things that can have codes, abstract class can have codes. Then strings, integers, reference coding, time and date can also have codes with them. So you get compound data types where you can have a date or a time, but you can also have a code that could mean the date of time, or could be a null flavor, for instance. And then you've got options for what the initial value of something is, or where it has a code, you can say which one was initially selected. So that explodes out what questionnaire means. So the truth of the matter is that so I'm going to go into some details about the questionnaire between the approaches, but questionnaire satisfies our specification of what a form is. It has all the bits and pieces for you to be able to talk about forms. Remember that I won't flip back, but that initial diagram where I said what a form was. It satisfies all of those things. It also satisfies all of the things that are in the ISO forms model. So if you want to, if you have some difficulty mandating FHIR as a standard, for instance, you can mandate ISO and vice versa, and you will get the same, essentially the same thing going on. There are some minor differences. So FHIR Questionnaire is better than ISO forms in the way that it specifies gating. So gating of questions is basically a Boolean property in ISO. It didn't go into the detail, I didn't go into the detail of modeling ranges. If the value range is between 5 and 7, then allow this question to appear, for instance. The next version will have that in, because questionnaire has a very nice implementation of that. Questionnaire model looks more like an implementation in a relational structure, as I said before. It kind of looks like a set of tables, whereas ISO is a class model. And you might find that when you're producing, if you want to make a user interface for people to create questionnaires, and we'll look at one later, you might find the class model actually is much more useful to you. Whereas if you're receiving questionnaires and you want to validate that they've got the right kinds of things, then actually the specification FHIR Questionnaire is much more useful for you to work out whether something that's arriving with you it meets the constraints that you want, is a sensible form. ISO doesn't let you easily hide data from your user. So that was a design decision, partly inspired by a lot of the work that we did around clinical trials that validated ISO forms, where you don't hide data from your user, because the FDA gets very angry if there's bits of form data on the form that the user couldn't see. ISO does styling elements in a way that FHIR Questionnaire doesn't really. And there's the whole bunch of stuff about little bits of text that are associated with the question. Is it the question number before the question itself? Is it some bit of explanation for the whole question? Are you explaining one of the individual values? There are lots of different bits of text that are called out and identified in the ISO model that allow you to, that have got more semantics, more import on the meaning of the questionnaire than in FHIR Questionnaire itself, which just says there's a display item. Question ordering, you have explicit ordering in ISO as well, whereas FHIR Questionnaire is very much based on the document order of the JSON document. So you load up FHIR Questionnaire, and the order of the elements in that questionnaire will be the document order of the JSON document. ISO's doing medium markup. FHIR Questionnaire in its basic form doesn't. but there's this thing called structured data capture we'll get onto a little later, which kind of gives you some ideas about how you might want to do that. They live in different metadata frameworks. So FHIR Questionnaire is a resource in FHIR land, and there are certain ways that you say bits about metadata about those and how you reuse definitions or relate definitions from questionnaires to other bits and pieces. Whereas ISO lives in this rich environment of metadata registries of being able to register data elements in 11179 part 3, for instance, data models in 19763 part 12. You can do process models in 19763 part 6, I think it's part 6. So you have a whole bunch of different kinds of models that you have the capability to relate things to. Someone cleared their throat there. Was that intentional, Steve? Stop talking, or was that someone has a question?
No, sorry, it was me. I didn't realise my microphone was on.
Sorry, Kev, no problem. So yes, there's also this distinction between, it's always worthwhile pointing out that in HL7, the notion of the information model on the left-hand side, as you're looking at it, and the knowledge model on the right-hand side is this way of reusing terminology. But that comes with some problems, because if you go and reach over to your term server and pull back a set of SNOMED terms, well, how are you sure what that set of terms are? I mean, you know that if you ask someone what a question on a form, eye color, and you have blue and brown and grey. Well, where do you put hazel? Is hazel a kind of, it probably is, isn't it? And you end up with when you introduce terms into fixed term lists, you often change the meaning of other terms. Now, SNOMED is well governed in ways that mean that when you do go and pull back a set of terms, then actually the likelihood is if someone's added a term to that, it hasn't massively changed the meanings of the terms that exist already. But implicitly, when people see a term list, they'll pick the best one. And if you add a new term, there's a chance that that new term might be better than the ones that were there already. So you have this problem of never quite knowing what the meaning of the stuff is in HL7, whereas it's more difficult sometimes as an implementer, but in ISO land, in SC32 WG2 land, then you specify the value domain. You say what the meaning was. You register a version of it with the ECL statement that went and grabbed that sort of thing. So there are advantages and disadvantages to both of those approaches. There's something that you need to navigate around. The FHIR approach, as ever, is quick and it's fast, and it allows you to get stuff done without waiting for national programs to get their act together. On the other hand, if you want to care for people in a uniform, non-postcode manner, and you want them to have the best care, then you really probably want to have some of these forms of standards, wouldn't you? So you really hope that the national program can administer all of these questionnaire definitions in ways that are really useful. FHIR Questionnaire is, they're coming to the end of the talky bit, and we'll get onto the demo bit after we have a break. FHIR Questionnaire is a basic specification for basic questionnaires, which cover pretty much 90% of the ways that you want to use these things. There's stuff behind that. There's an extended definition called structured data capture, and structured data capture has a bunch of extra things about it. So there's some enhanced behaviors to forms, which pretty much covers some of the things that are missing as far as the ISO forms model is concerned versus questionnaire. Some of the things you can do in ISO forms are actually in structured data capture. They're not in the core questionnaire definition. They're in this bit that they've been a bit more arm-wavy about their specifications. But it also comes with a bunch of stuff about where do questionnaires live in applications, which is strictly out of scope of ISO 19763 part 13. That's a model for forms, not how do you use forms, how do you generate software from them, how do you create workflows, all of those kinds of things, whereas these are all parts of that structured data capture specification. For instance, automatic population. Can you relate your questionnaire to previous bits of data in your in your system to pre-populate them and allow a person to say, yeah, actually the blood pressure, those are the blood pressures I'm going to sign off on, and I'm going to click yes for that. So this doesn't have the rigor of openEHR, which means it's very much easier to use. But again, the thing with openEHR is that it's all very deliberate and design oriented, the kind of thing that a national program might implement, whereas FHIR Questionnaire is like, oh, well, we can't wait for those guys. So yes, as said there. And quite a bit of structure capture, data capture is PDF spec. Their descriptions of behavior, their descriptions of the way operations should work, operations programs should work, rather than computable things that you can grab and instantiate a class model from and generate some code from. So be prepared to do some reading. I think I've covered that. So again, the difference between SC32, ISO SC32, WG2 and HR7 is 11179 shows its roots in relational and analytics data sets for big agencies in the US. You can use it and it is being used in more detailed circumstances, but it does look distinctly third normal form in that it expects attributes that are described individually and incomplete in completeness, whereas HR7 has had this difference between the knowledge model and the coding model and tries to separate those two things apart. So this comparison matters, at least in part because I think the ISO model talks about what a form is in an easier, more accessible way. You haven't got to try and wade through the rules and work out what you're dealing with. You know that, well, there's a thing called a section, for instance. And I think it's a better fit if you want to register a particular form and you want to offer that in lots of different ways. So if you want to be able to have a form and then make a paper version and a FHIR Questionnaire version, then I think the ISO model works better for you. So if you're a national program, you're probably going to look at FHIR Questionnaire and say, well, this is an implementation, a communications format. This is something that you generate software from or configure software with. But I've got a lot of stuff I want to say about this, and I can't say this inside this questionnaire definition. So national programs, big structured things are going to lean towards ISO, which is unsurprising, I suppose. It's ISO. Whereas if you actually want to generate some bloody software and get your job done, then you're probably going to look at the FHIR JSON serialization, because it does have the stuff that you need to get the job done. But hopefully, I think by getting to the end of that, you get to the idea that actually FHIR Questionnaire is not only good enough with structured data capture, it's pretty complete, actually, and will do all of the kinds of things that you'd want it to do when you implement that, or when you choose that, hey, here's a problem. Looks like it might be shaped like FHIR Questionnaire. We can use that to provide a solution to our customers. And with that, that's the convenient point where I stop talking about stuff and start showing stuff. So I think...
Yeah, we have got some questions. Yeah, we have got some questions.
Supposed to be questions.
Yeah, so it's interesting that in the question thread, number of people have answered the questions. So I just want to make sure that they have been answered okay.
We are talking about a 5,000-year-old concept. You know, I expect people to understand what's going on here. What I'm trying to do is map that inherent understanding of what's going on to this particular serialization that has utility with this part of the talk. So if people are answering their own questions, I must be properly, David.
So there is one certainly that didn't get answered from John, which does the string data limits in FHIR pose a problem for users who want to enter lots of text in forms?
So that's the text data type. So when we come to look at what this all means in the next part, you can see that the string and the text data type imply that you should provide either a one-line or an expandable widget to enter the text. I mean, semantically, the difference between text and string is a bit kind of
Yeah. So,
wavy,
so
but
John's specific thing is that strings shall not exceed 1 MB in size. Does that become a limitation or?
well, how much is 1 MB of text?
It's about 300 words. It's about page very 4.
I think that's probably enough.
I think that's probably enough, but I did wonder.
So yes, thank you.
Just a quick one. As a supplier, if we had a big blob of data like that, we'd just use an attachment with the form.
This is part and parcel of the standards process. The standards process, a bunch of people get together and they form a consensus about what should happen. But to get consensus, you end up with compromise, and you end up with lots of people who have slightly different ways of doing things. So what's a good way to use FHIR Questionnaire is a limited set of what could you use FHIR Questionnaire for. And so this distinction between string and text, the blurring between there covers a multitude of sins, if you will. You would hope that if a national program did stand up and start saying, well, we'd like you to use questionnaire more like this if you can, and we'll offer a translation service to map external models into our preferred way of doing questionnaire, then those kind of rules might appear that yes, we expect.
So Sarah has said, and I think this is a very good point, is that the large amount of text issue is particularly prevalent in mental health.
And
There's
in
a lot of
imaging, yes,
narrative.
Jonathan's absolutely correct there. I dealt with lots of imaging reports and pathology too. That it's often a feature of clinicians who, and particularly clinical scientists who respond to requests for opinions, is that they prefer to write some text rather than cut them up into bits of discrete data, partly because they're worried about their personal liability insurance, partly because they worry that without the context surrounding their text, someone's going to look. I mean, this is a request that I had from our path lab in OUH, where they said to me, Steve, I'm absolutely happy to put a staging here. I will fill a staging in every time that I fill one of these forms. So please do not show this in the report that goes to the clinician, because they'll look at the staging and they won't read my report. And so there's all bunch of sorts of psychology going on around the use of forms and where you can deploy forms and what the data is used for, and the understanding of the recipients of forms as to how to interpret them. But then again, I think to hark back to the stuff that Dougal said earlier on, this feels like part of the solution for us to be able to do more with what we have, or hopefully even a bit less. So I think these are questions that we have to ask in the wider sense of things.
Okay.
It's
Oh,
the API for humans, and humans are squishy, and it could poke me, and I'm not hard. So yes, quite.
yes. Steve's come in with a late one, which is surely it depends on the format of the text in raw text form, which is what I'd expect in FHIR. Which is just
That's more of an observation, I think.
yeah. Sorry, I think did Richard. Sorry, if you answer that, just lost that. Where's that gone? Yeah, sorry. I've just lost that question. I don't know what's happening there. Steve, would you like to come off mute and just ask?
Sorry, say again.
Yeah, so Steve, do you want to come off mute and just
Have I gone on mute again?
No, sorry, wrong Steve. Sorry,
Oh.
Steve Mallon. I'm sorry. You want to come off mute? Now there, surely it depends on the format of the text in raw text form, which is what I'd expect in FHIR. It's literally enough for a novel. Oh, sorry, sorry, Steve's making a comment there. I do apologize. And somebody, yeah, Adam has said 1 MB is a lot of text, more than 300 words. So I think we talked around that quite a lot. So I think the conclusion is that's probably probably enough. Okay, let's bring that to a close. Thanks for the first half, Steve and Dougal. You're both on after this. I think yeah, we will keep to the break till 11:30, so you do get an extra few minutes. So we will see you back at 11:30. Thanks a lot, everybody. Yeah, so Steve, over to the next part.
Yes. Let me just find out how to share my screen. I don't use Zoom very often. Apologies. So this one's, I'm going to be diving across lots of windows, so I'll try and make sure that my slides are as big as possible. But I haven't quite worked out how Dougal did that and got a slide display in a window. So obviously, despite Dougal's attestations, he is an expert at least that. So to recap, for the first half, mainly we talked to architects and devs working with the questionnaire model itself, rather than any particular questionnaire that was going on. So we looked at what a form is, what does ISO IEC think a computable way of talking about forms is. We compared FHIR Questionnaire to that international consensus, and we made some observations about the specifications and what they look like. So in the second half, this is more for business analysts, people making questionnaires themselves and wanting to structure their data capture. So we're going to look at how you might use it and how this works with the term server. There seems to be a plethora of FHIR Questionnaire tools appearing in interwebs at the moment. I mean, I just went to Google and I did a FHIR Questionnaire runner I typed in, and I found I have no association with AidBox whatsoever. This is just somewhere I found on the internet, and was quite impressed at how detailed the thing looked. So you can go to AidBox, you can sign up for a free account, you can create a license. I created a license here to use for the training. It doesn't last for very long. You can tell it where you want to deploy bits and pieces that it creates for you. And then once you've got a license, it has a bunch of different tools here. And you see about halfway down here, it says AidBox Forms that will help you create test patient encounter and observation forms. That's really, really cool. You notice I'm not approaching this as a developer. The bits of the software development that are involved with FHIR now are in the background. The business process of me thinking about what kind of forms I want, that's what my interaction here is. And developing solutions rather than platforms. We talked about platforms before. So there's another slide I missed. Right, yes, that was slightly out of order. So when you go on to the website, it gives you a form that you can use to record all the detail that you need to record to define a form. I love that idea. I love the idea that you're filling a form out and what you're doing is you're creating a design for a form. But this is the essence of here. We're creating a user interface to allow people to create valid FHIR Questionnaire records. It just so happens those valid FHIR Questionnaire records can be read by a machine and software can be generated from them. And that's incredibly, that idea that you work out the capability that you want. I want to be able to render any form, define that capability, and then fill the capability with content. This is the definition of the respect form that I want my clinician to complete. That's one of those things that allow us to do a lot more with quite a lot less, actually, if we're just play a little bit clever. And as you can see here, this is this bunch of different widgets, and you might recognize those question widgets from the item types that I showed in the diagram previously. Not going to use the AidBox tool here. What I'm going to do is I'm going to go with a bit of kit. So there's a project out of the National Institutes of Health in the US called LHC, and Kev and the guys in our transformation directorate have taken some of that code, all open source, all reusable. You can see my web browser now, and you should be able to see it says NHS Form Builder, Skunkworks. And they've instantiated that and connected up with various bits and pieces so that it was just the job and it works, and extended some of the functionality and provided some examples. And I'm going to show you how this whole thing works, just basically before we start looking at how it works with term server. So create a new form. It offers me with the questionnaire bit. So this is if you remember my questionnaire model, that let me go back to that here. So here we've got a questionnaire class. So that questionnaire class comes out in the form here, and as you can see, you've got all of the attributes on here that were as part of this, or at least most of them. And I can give my form a name, Steve's demo form. I can add a code to it to classify the form, so that would help me find it, and that's quite useful, really, because if I could, let's pretend that Steve's really successful and he gets to set up a form registry for forms that are used in the NHS, or that groups like NICE and the PRSB think are the kinds of forms we would like to use to care for patients. Finding forms is going to be quite hard because there's going to be lots of them. So putting codes on them so you can find them becomes very useful. There's a notion of workflow here, so we can give a status to the form. This is definitely draft. I can put the description, INTEROPen training. I can add a purpose. And then I've got some stuff here. I'm not going to specify terminology server because this is already wired up to the NHS England terminology server. Then I can create some questions. So here I have a questions tree. You remember I said that this is a tree of, a form is a tree of sections with questions at the leaves. Well, question tree right there on the side. So here is that, that's the data type. Yes. So if you remember when I came back here and I said that there was this attribute here called type code, questionnaire item type. And what that does is that tells you what this item record means. And then there are a bunch of rules for you to say which of these attributes on an item can be used. Well, if I now go back to where I am in my browser, you can see that all of these are here. And I can, for instance, in string, I can set that item type to be header group display. Okay. Now, what I've done then is I've created a section, so I can say Steve's section. I have a section there, and I could put some help text. Let's put some help text. Okay. I have some advanced fields here. I'll talk about those in a little while. So I can add a new child item to that. And as you can see, the tree's building. It's numbering the stuff for me. And I'm going to, what is Steve's I? So I've put a question in. Now I could have a data type of a string, which is what, side of A4. I could, someone somewhere surely might write poetry about the colours of my eyes. I'd love to find that person. But there's plenty of stuff you could put there. You could put a text if you want to, or you could put some choices. Or if you had a Pantone number, you could make it an integer, I suppose. But let's put some choices here. So I got a data type, and I can put some answer choices. I can put blue, which is not the true, and I can't type either. Add another answer, and I can say brown, which is what is true. And then I can add grade, which is life cycle. And I've got some stuff around here. For instance, I could create a default mapping here now and say, when I say blue on this form, I mean this code in this code system. Or I can actually say what the score of this is. So if I was making something like an evaluation score, then I could put those scores on, and then I can use some of the facilities in FHIR Questionnaire to calculate the sum of the score late and display that at the bottom of the form as part of the advanced fields. I can also say a default. So let's put the default as brown, and that will mean that when we create an instance of the form, then it will have that as its default answer. And we can add another question. So if I add another item after this, it will add it to Steve's section. And I'm going to be, trivially, I'm going to say, how many guitars does Steve have? Because that's a non-trivial answer. And because you can't have half a guitar, I'm going to make it an integer. So let's go. Let's preview it. What have we got? So we have a form. We have two questions on there, one which is a drop down and one which allows me to enter an answer with. And in the background, what this has done is it's created some JSON. And as you can see, so here's my here's the item of a type choice. And here are my answer options, the different colors, the codings of the color. I'm not sure how you do this, Kev, but you ought to be able to get the answer to that out as JSON too, because there's this thing called questionnaire response, which is the JSON of the filling in of the form. So it's the data that the form has created. We'll come back to that a little bit later. But you can see this is really straightforward. It's really, with a small amount of training, practically anyone could sit down there. If you're capable of opening up Word and working your way through the Word interface to make a form so you can print off, so someone can fill it in, you can go through this and make a question tree and add questions to it and start to encode the business processes of your clients or your department, if you're working within a department, in a structured way that you can take the FHIR framework and use to animate so that people can create. You're doing model-driven software engineering, but what we've done is we've broken that business process apart in a way that means part of it is accessible to someone by completing a form. But back to the slides. So, what might I want to do when I'm creating a form? Yes, I can put questions in, but I want to be able to get some stuff. So I don't want to reinvent terms. I don't want to continually list stuff and then have to bind it to the term that it means. I'd like to go and get some of those terms, please. I'd also like to use the knowledge model of SNOMED in that. And we can do all of that using some of those options in the choice. So if I go back to my Steve's eye color, you can see that I've got other options here. I've got SNOMED answer value set or answer value set URI. And so those things then go and speak to the term server that I specified when I did the metadata about my form to go and get those things from. So I might want to go and get the list of drugs. Where can I get a list of drugs from? I can get a list of drugs from term server. So this is an incantation, a little questionnaire with one question that goes to the term server and pulls back a value set called VMP. So VMP is the list of drugs in DM&D. It's a particular one that Nicholas said that I should use rather than just the one that Dougal provided, which worked as well. It was brilliant, but Nicholas goes, no, use VMP, Steve. So I'm using VMP. So if I go back to Kev's demo here, I can open a questionnaire. No, please. And I can go and pick one that I've already done. So here is, don't just love Blue Peter. I'm a Blue Peter boy. I never used to watch Magpie. It was always Blue Peter. Anyway, so this is, did that open? Hang on. Let's do it this way. Start with existing form, import from local file, continue. Valid set UI drugs, continue. Right, this is the DMD example. It has one question, and it is an answer set value URI, and it goes and gets this answer set from the server. So I can preview that, get my one question, and what do I do? So as you notice, I've got a little widget in the corner that says find. So that's dependent upon this option here. Obviously, the DMD, I'm not going to ask for radio buttons. That would be silly. Drop downs, it has some nice ways of doing drop downs, but really there's still too many terms. So I've selected an autocomplete widget. You might hope that at some point there would be a SNOMED browsing widget that observed the knowledge, the structure of SNOMED or the structure of a FHIR value set, and could use that structure and present that in a way, but it's not in this particular designer viewer tool. So go back, then I can start typing aspirin. And as you can see, what it's done is it's started to find me all of the mentions of aspirin in the VTM code set that's available from term server. So any kind of master data that's on the term server, so we could be looking at clinician identifiers, for instance. Who's the responsible clinician in charge of this process? And you go and find Fred Dibney, who is your boss and who you're making the record on behalf of. You can do that. Here you've got, I'm not sure if that data's there yet. I think that's Maxine's job to work out how that actually works. Or what the ONS code is. You can go and look up ONS codes. But here, as you can see, I've got all of the drugs, and I can go and find all of the drugs. You see? All really cool. The example Dougal provided, it gives the individual dosing kinds too. So you get the blister packs and all of those things that are up there. It's really, really powerful stuff. So if we go back again, back to my slides. So that's done master data, and there's a slide there to show you it working. I showed you when I did the Simple Steve example of iColor that I could add actual codes to it, and I could map those codes. This is what that looks like in the underlying JSON. So you can see that I've said there is a SNOMED code, system snomed.info. There is a SNOMED code of this value here, which I want you to display as release to family. So this is a question that you might find on a delivery of placenta form, which we've been playing around with in the background, and I'll show later on. I can also get a value set back by doing a URI, and I showed you the URI. Sorry, I got a little ahead of myself there with the DMD. Oh, no. Sorry, DMD is master data. This is a value set that is a set of enumerations that lists data dictionary care professional staff group for maternity. So that's different from going back and getting a master data list and putting that and using that on my form. This is about getting NHS terminology. And I have an example for that already. And in true Blue Peter fashion, I am going to load that up. Just let's navigate back. Start with existing form, import from local file, do my browser. I'm looking for there. Continue. So look at my questions again. So as you can see, I showed you the JSON here. So this is the answer value set URI. I've got the URI here. I've got a text of care professional staff group, which I effectively can also be controlled from the data dictionary. And you see it's all there in the user interface. So when I do a preview on that, you can see that now I've got all of the kinds of things that even with all those capital letters we so love from the NHS Data Dictionary, I can flip that over to a drop down, and then I can have, and that will drop down and pull back all of the 17 items. You see, it's shown me 14 of those. Or I could go and I could do it to radio. This is not too big a list, so I could do a radio button. And then that would be the ultimate easy. I can just say, nurse, bing, I'm done. So you can see the power here of defining the things and having a framework to turn your specification automatically into software. Right. Next example. We have these things called ref sets. So ref sets are where people in Pete's team decide that there are a bunch of terms that are really useful to be used in a particular context and don't want informaticians like myself who don't understand medicine as well as I would need to create a ref set. They suggest all of those things for us. And if we know that ref set exists, we can find the metadata about it, we can search it, we can go and grab that ref set, and then that set of curated concepts is available to us. And of course, what we then do is then we start to solve this problem of what does it mean when I go and point and grab at something from the term server, when the stuff on the term server can change, because the ref sets are managed by Pete's team. There's a governance process around their changing. The fair versions of them are identified in ways that we could point to a particular version if it was really important. And there's also metadata that they'll maintain so that if it's necessary to work out what this form that was completed on this date, what did the clinician actually see when they completed the form, then the metadata is part of the governance process so that you can join the dots back up and be sure of what options were offered to the clinician. So here you can see we've got an answer value set. We've got a URI to a ref set. So, and this is a SNOMED expression here now. So we're starting to get into expressions, starting to ask the Onto server to do some work for us, not just go and look in the index and pull back the stuff we want, but it's still looking in the index and finding stuff. But we're starting to venture into a whole bunch of nice, interesting SNOMED stuff. So what does that look like? Let's go back. Start from existing form, import from local file, continue. That would be value set by ref set. Yes. You can look at the question. As you can see, the encoding isn't in there. It's dead easy. Right? Ref set / concept code of the ref set. SNOMED edition, the UK edition, which is one supported on the server. And then I can preview that. And then I can go with, and you can see that I've got a bunch of options now for an early intervention in psychosis, which are the things in that ref set. So I can, so if I'm doing forms about mental health, for instance, as was said, people like to type lots of stuff, I can point to bits of SNOMED and make it relatively easy for people to come back. And then separately, you can have a chat with Pete's team and make sure that the value set, the ref sets that you want to use and want to get data terms out of are there for you and maintained for you in ways that mean that you don't have to worry about going to SNOMED all a while, that it just works for you. You go to the term server, you ask for the right ref set, you get the right terms back. Okay, so skip logic. This is lovely. I really, really like this. So let's use this as an example. Let's add a second question. Insert a new item after this. Skipped. I'm going to call it skipped question. And it's going to be, it doesn't really matter what the data type here is. What I'm going to do is I'm going to open the advanced fields box. And what this comes up with, this thing, is conditional display. And there's other bits and pieces here, but I'm going to talk about conditional display in particular. So there is already a question on the form. If there were more questions, it would list all of the questions for me. So you see, I don't have to remember, I don't have to type the question exactly how it is. Interface, has said, you want to refer to a question on this form, here are the list of the questions, so I can select it. And then if you remember when, I think I had an example of this on. There was answer constraints, read only, enable behavior. Right, okay, so that refers to another class. Sorry, I don't actually have that class just to show you how that works. Let me go back to the example. So I can do an equals, and then when I do my equals, no, it should go, and it of course isn't actually doing this now, is it? It would not, it would do that for me. It will go, and I have done this before, and I'll show you some examples, and retrieve from the term server the term. What's it saying? Apology. So what that does normally is it will go to the term server and fetch back the list of terms for early intervention psychosis so that I can say which ones I want to skip. So let me go and find something that I know works. Cancel, I don't want to close this tab. Open form, start with existing form. File. The problem with demonstrating eternity is probably in set. Yeah, we'll load this example up. So this is a much more complicated example that we've been playing around with, and there are a bunch of stuff here that that has these different examples in. Let me just check where I am in my. I think this is scheme. It's where I am. So for instance, if there's a couple of nice features here I'll show while I'm actually on this form. Placenta delivery method. We've gone here and issued an ECL statement, an actual query to the Onto server that says that I want concepts that are child concepts of this term to come back and be the value set for it. And I have a second question that uses the same concept, which are other methods attempted. Now you see, this isn't properly SNOMED coded. There are ways of saying that these were attempted and weren't successful, and this was the successful method. But you can see that we've got a drop down with a repeating question here that you can put multiple answers here. But when you actually specify the real method, you just do the one there. So here's a question: further anesthesia required, Boolean answer. And then from that, there's a question after that, anesthetic used. And then in the advanced fields, you can see that it selected the question, it's done the operator, and I've specified an answer. And then that will go, and when I preview the form and I go down and I go further anesthesia required, it will then pop up all of the questions below that are only appropriate if I answered yes to that question. So it skips part of the form. It allows you to unfold the form and show the bits and pieces of it that are relevant to the questions that have been previously answered. And of course, that's gone and found a list of anesthetics that are quite a long list of anesthetics that you might want to use. Is that actually the DM&D? I don't remember. So let's go back to the slides. So yes, skip by value set selection. It will retrieve, didn't today, but it will retrieve the terms on the term server and use that to conditional respond to what you've used so that you can build in the term server into your logic of your form, not just simply as a set of terms, but also to trigger logic as things go. Here's a specific example here. So this uses and goes and finds the temporal logic of a situation of explicit context here, for instance. And then for when it says current, specified or past and specified, that actually then ensures that it pops up a time window so that you can put the time and date in when you know what the time and date is. I think it's that point for that. Yes, so that example is the next one that comes up. So back to Kev's tool, open another questionnaire, start with existing form from a local file. And this is the situation of explicit context, continue. So this is quite interesting in many respects here, in that what we're trying to do here is in some respect get over the problem of post-coordination SNOMED and FHIR and HR7, which don't really play very nicely for it. So what this is a form for recording something that SNOMED calls a situation with explicit context. And there are a bunch of stuff on here. So for instance, there are skips. So I showed you that skip there where you only get a when question if you specify that you know the time of the situation that occurred. And then there's also a radio box that says whether this is a finding or a procedure, and then it reveals two different bits of the form at that point in time. So and it also has some repeats in as well, which is really cool. So situation of explicit context, I've got a finding. It's not in the default context. It's of the person. The temporal, past specified, I've just left as a free text field. Thank you, app. Associated finding. Severity. Finding certainty. Add another. Add another. Kev, have you crashed me? Add another, we'll add another one of those. I'm afraid it's just gone. Let's try it with the National Library of Medicine, shall we? Form rendering, visit, load from file, situation of explicit context. This did work on this one. Add another, yes. So here, that's a really generic way in your applications that you could say, look, I want to create a couple of widgets for my people who are using my application, and they're open-ended ones. They're stuff that they can record procedures or findings or observations that are relevant, and you would narrow down the SNOMED trees so that it picked a ref set or an ECL constraint that was the stuff at the other end of that was appropriate for the particular setting that the form was used in, and then allow them to just say general clinical statements into the record. And that's really quite cool, actually, I think. There are so all of these bits and pieces that I've been pulling up and showing to you are all available. They will all be made available as part of the pack that comes along with this. So you've got some sample code that you can have a play around with. If I go back to this one here and pull that up, there are some really nice. I need to be in the form builder, don't I? There are some nice bits of ECL stuff in there, if I can find them, where we've put some timestamp. So there's a timestamp potential delivery method, other methods attempted, some delivery notes, completeness, structure, that's the string, that's just a string. Maybe I didn't have it. You can issue all sorts of things here. Was it the condition details? Apologies, people. We stripped those out. So you can say things like minus. So you can say find me all the different types of adenocarcinoma, except ones under this tree. And the stuff that Dougal showed you with all of those keywords that structure that ECL stuff, they all work, and you can use all of those inside your ECL statement to go. I'll add a couple of examples if I can't find where they are in what I've demonstrated. So coming back to that point I made earlier on about FHIR Questionnaire being complete and conforming to the international model, there's another format of forms in open format of forms that's in the healthcare space as part of openEHR. And it is possible, indeed completely possible and doable, to be able to take an openEHR template, which is their specific version of the word for form in openEHR speak, and then translate that into a FHIR questionnaire. So this is something that Nicholas knocked up in an afternoon, whereby we imported the mental health triage from the openEHR template on clinical knowledge management right off the web. We annotated it according to the ISO model. So Marrow Data Mapper, you may be familiar with that tool that we're developing alongside the University of Oxford. Marrow Data Mapper allows you to profile data models, and one of those profiles is the ISO forms model. So you go along tagging up bits of the data model with what it is in the ISO forms model, and then you can export it as a FHIR questionnaire. And as you can see, what we have here is we have the JSON for the FHIR questionnaire that came out of the Marrow Data Mapper tool, and then this is that questionnaire loaded up and ready to go in the LHC tools that we've been showing. So it isn't just simply about, you can go and find previously developed, possibly even assured forms and offer those to your people to help them use it. Of course, there's this thing called questionnaire response. I am nearly finished now. This is the last but 2 slides. FHIR questionnaire response then emits the data you've used and completed with the questionnaire as a JSON file, and then that can be sent to a FHIR server, and the FHIR server will persist that for you. And here's an example of a questionnaire response done. I'll skip over that. There is a tab on the form builder called SDC demo, which you can find somewhere around there. And my clicking capabilities have gone to pieces. Have a look at that, because that's quite interesting. It starts to show the stuff in context, and you should have a play around with. And that's everything that I wanted to say. Questions, David?
No, thanks a lot. I'm just trying to see if there are. I think many of them have been answered as we've gone along. Yeah, I think we'll let people communicate between themselves, because of quite a lot of, I think nearly all of the questions or points made here have been answered by others. So thanks a lot for that, Steve. I think it really brought everything to life.
Yeah, I think we're good. I'm looking at this stuff down here, and I think this is all right. Again, people have been answering the questions.
Yeah.
I think this is a general thing that we've noticed about FHIR patterns in the past, is that fast is great when you're on the ground and you have to solve a problem, but it does create problems for those people who want everybody to go in the same direction. And there are a couple of observations made on there. Yes, there are some things, there are some ways we might want you to use questionnaire ultimately, although we're not constraining that at this point in time, that make it easy to join dots. The tool that Kev has stood up, for instance, that's really, really helpful, that it automatically logs on to the terminology server, allows you to do that. What we might want to do is customize that tool a little bit to enforce some design standards, for instance. And this is a lovely thing where what we're doing is we're turning enterprise architecture into data, into the designs in data of the forms that we're using. So by that, then the constraints that stop you from doing something stupid when you design your form become enterprise architecture constraints, but they are encoded in rules in ways that mean that people do things the right way by default, and then can call out for some support if they need to do something that's different for a particular circumstance. So I think it's a really exciting thing. It allows us to get hold of a whole bunch of stuff, reduce variability where variability doesn't need to happen, and allows us to start getting a handle on what it would be to have an enterprise architecture for the NHS, which I think is very cool indeed. Thank you.
Thanks a lot, Steve. Thanks for the questions, and I think there's been really good conversation in the comments. So appreciate everybody's contribution in that. I think we're in the home straight now with Dougal. So let's hand it back to you, Dougal.
I feel like we're in the opposite straight. I'm about to go and try and demo things, which is always a little bit risky. Hello again. Right. So let me share my screen. So in this section, we're going to show you a little bit more about the tools that are available with the terminology service, and also, I guess, focus on showing some examples of how you apply them to a common pattern of problems, and also how you use them, how you might use the things that you create runtime, and also how you make sure that you're able to propagate and share the things you build with other people. Can I just check my screen is showing, right?
No, not yet.
I can't see it yet, Dougal. I can now.
Good job, I checked. Sorry, Zoom's a little bit alien to me at the moment. Pandemic seems so long ago. Right, so yeah, this section is mostly hands-on. You'll be pleased to know there's very few slides. We'll start with the tools. So you don't have to worry about all of this picture, but I just thought it's worth I guess, giving you a bit of context into what you're seeing when we're doing things. So in this diagram kind of lays out the terminology service as a whole, and you'll see the things, the blue clouds here are FHIR terminology services. They're Onto server instances. And there's a couple of boxes here, which are Snapper and Shrimp, which are basically web apps that allow us to do things against the FHIR server. So they just use the FHIR APIs against the terminology server, but they allow us to build content, view content, or explore content and do things with the APIs. But anything those tools are doing, you could build your own tools, or you could integrate to the same APIs to build the workflow or the behavior into your own systems. So you'll see Snapper, which is really the tool that does writing, so reading and writing. So it's an authoring tool. It allows you to author terminology artifacts. So that's the value sets, the code systems, and the concept maps. And Shrimp, which you've already seen reasonably extensively, allows you to browse the terminology and also build things like ECL expressions and explore value sets and the result of ECL logic. The other component just to highlight here is the syndication server, and we'll come on to that a bit later. But that's kind of the mechanism that allows sharing to occur between people. So there's sharing happens within a server. So if you have a terminology server instance, obviously the content can be made available to anybody using that server or subsets of people using that server. But the syndication server element allows that content to be shared with other people's terminology servers. So the NHS England one, for example, at the moment has 5, I think, other terminology servers, maybe more than that, that syndicate their content from the NHS England one, or syndicate a portion of content from them. And basically that just lets another terminology server subscribe to updates and changes in another terminology server. We'll go into that a little bit more detail, but I just wanted to give you a bit of a layout of where what made up the service and what you use for different aspects of the solution. OntoCloak is the authorization server piece, so that's the bit that allows you to integrate to existing identity providers and provide a fairly easy way to log in and securely access and control access to terminology and the update of that terminology. But you'll see here, and these kind of green lines are really FHIR API calls. So you can see that clients, clinical systems, and other Onto servers are also able to communicate with each other. And when we're talking about runtime use, we're really talking about these things up here that may be doing or making calls to take advantage of content that's on the server or maintained as part of the service. So I think the easiest way to show something and to learn something is to take a simple example. So we have a very simple CSV file which represents a very typical pattern that you'll come across or you'll be familiar with, which is you've got some data, it has been locally defined and locally stored in a system and is kind of fairly meaningless outside of that system. So in this example, what we're trying to do is take something that is locally defined and turn it into something that is normalized and understandable by the wider system. So this here is a small representation of allergy descriptions and some local codes for those allergy descriptions. Now, this is just a pattern. So this is exactly the same pattern that I think pretty much the whole of NHS Scotland is using for their labs data. So they're following this pattern and using the same tools and the same syndicated instance that we're describing here to standardize and normalize all their lab results across Scotland as part of their national LIMS program. And as part of that, they're building all the maps to a similar pattern I'm going to show you here to allow them to translate those codes to their SNOMED representation, as well as backwards to their existing, I guess, legacy codings and similar to be able to talk to the older parts of their ecosystem that are not able to change along with them. So this is just a very simple pattern, but that pattern gets repeated all over the place and could be used for any type of data. It doesn't have to be allergies. It could be diagnoses. It could be lab codes. It could be any kind of data you have. It could even be organization codes. So as part of demonstrating the pattern, we're going to go through a series of steps. So the first thing we're going to do is turn that into a standardized representation. So the standardized representation in the FHIR server is a FHIR code system. So step one is to get our authoring tool. We'll go to Snapper, and we will just make sure that we're logged in. Again, this is the authorization server, so it's simple login, and we're going to create a new code system. So in this example, we will just give it a name that we'll find easy to find. So we'll just call it INTEROPen 123. We'll give it a URL. So this is its business identifier, and we'll just call this allergy. And I think that's probably all we need to do at this stage. So we're just setting up some information, metadata essentially, to describe this code system we're creating. Obviously, in the real world, you would use a structured naming pattern and a meaningful business identifier. But in this case, we're just kind of cheating a little bit to make the demo easy. So we're also going to define a value set, which we will just call that, which is basically the URL for the value set that represents all the codes in the code system. So the next thing we're going to do is take the extract of the codes and the descriptions that we had and import them into this code system. So this is the same CSV file that we were just looking at. It's a CSV file, and it has a header row, and this column represents the code, and this column represents the display. So it's just going to, there's multiple additional options you can have, but this is just a very simple example. We're just going to import those codes in. So now we have loaded in that CSV file into this tool. If we want to, we can provide, additional metadata. In this case, I think we'll probably just keep it pretty simple, but the tool supports you to add additional information as well as some narrative to give it some context. And then what we want to do is upload it to the terminology server. So this at the moment is just local. What we're trying to do now is say we've got a FHIR representation of this code system. We want to put it on the server so we can do things with it. But before we do that, we're just going to validate it, make sure that that the FHIR code system we've created is all legit. And we got a prompt saying, okay, there's an information warning that says code system should have a stated value for case sensitive. So that's a good bit of good practice. So we'll go back to metadata and we'll say that it's not case sensitive in this case. So now if we go back to upload and we do validate, we should find happy days, no issues, all good. So now we're going to upload that code system we've just created to the FHIR server. Code system successfully created, all good. So now if we go to Shrimp, our browser, we should hopefully, we just log ourselves in and we go and look for SNOMED or INTEROPen 123, we can see we now have our code system in here, and it's not very richly described. It's just codes and displays, and it's got its URL. But you can see very easily it's now part of the server, accessible to anybody, and anybody wanting to access it via the APIs could just go and make APIs calls against it. And this is now a terminology artifact we can use. So step one, represent the local code system in a standardized way. So we've done that. The next thing we're going to try and do is now build a concept map that allows us to represent the relationship between those local codes and a better code system, a richer code system like SNOMED. Okay. So what we're going to do is we're going to go back to our Snapper tool, but we're going to go to our Snapper map tool now. And again, we're going to log in and we're going to create ourselves a classic map. So in this case, we'll stick to the naming convention to keep it easy to find. 1, 2, 3. We'll give it a version 0.1. In this case here, we need to reference the existing code system that we have created as the source of this map. So the source of this map is going to be this local code system. The target's going to be SNOMED. So in this case, we can go and search for hopefully INTEROPen 123, our code system, and we're going to have the value set that being all of the codes in that code system. So that's basically saying the left-hand side of our map is going to be defined by that code system that we have. So everything in it is that. And the right-hand side of our map is going to be SNOMED. That's our target. And I'm going to make a bit of a deliberate mistake here and just show you what it looks like. But at the moment, we're saying, this is just a map to SNOMED, but it's not a map to a specific bit of SNOMED. It's just a map to the whole of SNOMED. So now we get into our sort of mapping context. And again, what we can do is we can import our codes. We'll go back to our file, the CSV file, got one row in the header. We say the source code is in this column and the source label is in this column. Again, there's a bit more complexity to this if you want it, but that's the simple version. So we can now import those codes into this mapping context. And if we want to show the source codes, you can see we've got the content of that file now in the mapping context. So now we want to try and do a mapping, right? And this is where the sort of deliberate mistake comes in. So the tool will help you to do that. So I can say, let's take this row here, like paracetamol, right? I want to go and find some suitable matches for paracetamol. And you can see that there's 1,521 matches. And most of these are sitting somewhere in the drug space, right? So they're not in the allergy space, they're in the drug space. So this is really not very helpful to build the map. But what we can do, if we go back to our what we learned earlier, is rather than have ourselves try and map to everything, we can constrain the target of our map using a value set. So we'll go to our we'll go back to shrimp, right? And we will go and find our hierarchy that we're interested in. So in this case, it's going to be allergic conditions. So if we go and look for allergic conditions, and you can find this, obviously you need a reasonable understanding of SNOMED to do this accurately, but it's not too difficult to go and find a thing you're looking for, look up the tree, find the hierarchy, and kind of infer a sensible constraint you might want to put on it. So in this case, we're looking at, we want to map our local code to something that sits under allergic condition in the hierarchy. So we're going to build ourselves a value set on the fly that says, I want to have everything that is under allergic condition. So I could do descendants of self, and you can see now I've got a number of concepts that's much smaller than 1 million, which is targeting the target of our map at an area that we know based on the context of the information that we have as input. So I now just copy that value set, and I'm going to now update my target to be still SNOMED as a code system, but the value set that's represented by that ECL expression. So now I've done that, if I repeat the same test for paracetamol, you can see I'm only getting sensible answers in the context of the use of this map. So not only does that help me if I want to build a map, so I can just drag things across, right? Not only does it help me do that, but it also helps the tool help me to do some things automatically. So nobody really wants to be having to do a load of legwork to produce these kind of maps. What they really want to do is get, some help. So what I can do is I can select all these codes and I can say auto map. And we'll overwrite the existing target. And this will send a bunch of API calls over to the server, and we'll see if there's a sensible map available using some algorithms defined to do essentially lexical matching against the source text we've got and the context of the value set we've defined, including all its synonyms and representations. And you can see now, hopefully, that if we look here, we've now taken a local list, and we have converted it to, or provided a relationship to an equivalent SNOMED code. Now, obviously, this is a demo, so and it's a small list that's relatively well specified, but it's helped, right? It's quicker for me to do it this way than it would be to do it all manually, and it wouldn't normally be 100% perfect, but it's usually 80% right. And if you need to change it, you can just see if there's any other suggestions. In this case, there wasn't, but maybe under paracetamol there would be. No, in fact, it's decided they're all right. But if there's multiple suggestions, you can pick a different suggestion. And obviously, it needs reviewing, but it needs reviewing rather than creating, and it needs editing and improving. But hopefully, you can see that it makes the process of getting a map together much quicker than it would be to do it manually. And in the case of what they're doing with the labs project in Scotland, they're doing this with thousands and thousands of codes. And they're doing, a clinical review process that improves the map and validates the map, but uses the auto mapping capability as a help, as an aid, as a sort of an accelerator. So in this case, I'm gonna select them all to be draft. I'm going to leave them all as inexact. and assume that at the moment the auto map was correct. So let's just have a look and say, so now we've created a map. So this is the representation in Snapper. What we want to do now is let's put that as a I can't remember what we used. Let's just keep it as INTEROPen 1, 2, 3, and we'll just do, just to make it easier to find later. We can now upload that concept map to the terminology server. So with a bit of luck, that's now successfully uploaded, but we can see it is up there. So now we've taken a code system, we've used the tools to help us create a mapping, and we've uploaded that map as a FHIR representation, a FHIR concept map. So we built our concept map. So now what we want to try and do is see, well, how do we then make use of that? So in this case, this would be, you know, runtime translations. How do I pass a message through a system and call an API that lets me translate the code that I've got in my local code and turn it into something that I can share with the wider world that makes sense to them. So I'm going to go to Postman, just going to get myself an access token so I'm all good. And we're going to take a translate example and slightly adapt it. So this is an example, and this is, I guess, one of the benefits of a standardized representation of terminology. So this is a concept map translate operation. This is what we're using. It takes a few parameters. In this case, we're starting with an example that is a map that converts from SNOMED to CTV3, or in this case, we're using it in reverse, so we can do a translation. So in this case, this was SNOMED to CTV3, sorry, CTV3 to SNOMED. So we're using that to CTV3 code, and we can see it comes back with the equivalent SNOMED code of 19660704. So this is a map. This process works for independent of terminology. But what we need to try and do now is remember how we define these things and start replacing these parameters with our definitions. So if we look at our metadata for this, the URI for our concept map is that. So we'll replace the URL for the concept map with this. If we go back here and we say, what's our source code system is that. And our target is still going to be SNOMED, so that's fine. We're not going to run it in reverse in this case. And if we go back to our code, let's take code 101. Okay, so same API, same pattern. I've just passed a few different parameters in, and if I'm lucky, we're going to get back a translation that is using that concept map to say that 101 is inexactly equivalent to this SNOMED code. Okay, so it's really quite easy to take a pattern, reuse that pattern, and apply it at a pretty decent scale to solve the sort of the challenge that you have of understanding each other's data or understanding different ways of the data is represented, and in lots of cases improving the way that data is represented to make it more usable in the wider system. I can obviously do more complicated things than this. I think I probably can show how you do this in reverse as well. So we can run this in reverse. We'll have to reverse these things round. So we change the source and target, and now we're passing in that SNOMED code and running it in reverse. And you can see now that if I run it in reverse, I get back out my local code. So if you've got an interface passing information one way and back the other way, you can use the same artifact you've created to run it both ways. So that's kind of a quick overview of runtime translation. And as has been sort of, I think I put in the chat responses, these kind of operations, they're highly cacheable, so they scale really well. And you know, genuinely the response times, you know, this is a round trip to a server. It's really quite quick, even without caching. But if you put in place a local cache, or if I run this multiple times, the caching will speed it up, and also won't put any additional load on the server because the answer hasn't changed, because it's the concept map hasn't changed. So next thing I might want to try and do, let's take a typical scenario, right? I have this list of local codes, and I've got an interface built to translate them. But what often happens is that somebody, well, let's start with let's check that it's right first, right? So we need to get our value set. So in this case, this is saying I'm going to do a value set validate code operation. So this is a simple REST API call. I'm going to validate that my value set. So I'm validating against the value set. I'm validating the code 101, and I'm validating the system that goes along with that code as being the code system I created. Just for reference, value sets can contain concepts from multiple code systems, so that's why you need to put a pairing in here. So value sets can have, you know, SNOMED codes, ICD codes, all present in the same value set. So if I now do a validation, you can see my validation result happily is true. 101 is a good code in my system. If I made that 199, it's not valid. So a typical situation where you build your map, it's all good, but somebody goes and adds another local code and your map doesn't know what to do. This validation will help you detect that. And also, if you're the receiving system, you know, on this, you'd be able to do that validation and go, no, hold on a second, we agreed we were going to exchange this list of code bound to this value set that was defined as all these things, and you've gone outside of that. It allows you to check that. And you can also do, in this case, like this is valid 101, right? But this is ranitidine. Okay, so what I can also do is I can check that not just the code's right, but the display value's right as well. So if I do that, we're back, we're still good, still valid, happy days. If I was to change this to ostrich, right, I'm allergic to ostrich, this 101 has now moved to ostrich, it's not valid anymore, right? So it allows you to maintain that quality bar that's critical for doing successful interoperability with other systems. Just see where we are time-wise. So we've done runtime translation, and we've done runtime validation to pick up errors and changes. And hopefully you can see that both the tools help you build the artifacts you need to use in a standardized way, and they also very, very easy to use without having to know too much about the specific nature of the code system or the differences between code systems. Allow you to use the same API calls to the same pattern to achieve the same result, just with different data and different context. So syndication. So when we were looking here, we have the syndication server, and what we're trying to do as part of the sort of network of the terminology space is try and make it so that everybody adds value to the overall ecosystem without having to keep repeating themselves. So the syndication process enables you to essentially share useful artifacts from either the top of your kind of organizational tree. So it might be, in this case, NHS England National Release Centre. Allows the lovely people up here to deal with getting things like SNOMED and ICD and DM&D all represented correctly. It allows you to then just pick up and syndicate from them the content and put it into your local system, or indeed even your local terminology server, to do additional things with it. And that sharing can be either from the National Release Centre kind of instance, or the national instance, down to an individual regional one, or an individual local one. But it also enables it to work back up the other way as well. So if you take something from the national instance and you produce something useful that elaborates on that, maybe adds a map, maybe adds some value sets that are useful, you're able to both share them back up to the national instance, but you can also share it between regions or between instances, so that you don't have the situation where you've got everybody trying to build a map between a GP system and another system, when the GP system is the same in multiple locations and the other system is potentially the same in multiple places. So it allows you to basically collaborate with other people to build standardized shareable artifacts and essentially build the body of knowledge, rather than everybody continually repeating the same process to get to the same relatively basic point of defining the critical artifacts they need to manage. And it also means that, and this is I think an important characteristic of the system, is that we've probably all experienced the pain of people having different agendas moving at different rates with different processes. So this doesn't mean you're ever constrained by, it means you're not unnecessarily constrained by only one set of rules or one set of context. You're able to use what's there and elaborate on it, improve it under your own autonomy if you need to. So everything here is standardized artifacts. The syndication process is based on an atom feed, so it's entirely standards-based, and you can just subscribe to it, and you can get told about changes, and you can decide whether you automatically pull them down or whether you selectively pull them down, and all that is managed through the syndication process. So just to give you a little bit of an example of what that looks like, here's a atom syndication feed for SNOMED from the national system. So you can see this is just an RSS feed, and you can see that there was a new release, I think yesterday, of SNOMED CT, and you can see that this syndication feed gives you a pointer to where you can download the index version of that file, and it gives you a little bit of metadata around the version. And this isn't just good for SNOMED, it's good for any artifact you create. It could be that code system we just created as a demo, it could be the concept map, and anybody can subscribe, using a feed reader. So you can have, in this case, I've got a subscription to all the SNOMED indexes, all the DM&D indexes, and all the, I think, external content indexes. So you can see that, yesterday there was a new monolith release, 3 days ago there was a DM&D release, 10 days ago there was GTIN. If we go back a bit further, we'll probably find some other things that, legally restricted codes, all this kind of thing. It's a mechanism that allows you to find out about new content that has been created. And as I said, you can either, in the case of potentially systems that you entirely trust or entirely depend on, you can automatically subscribe to everything. Or in the case of things that you might just be of interest, it gives you an option to easily go and fetch something and maintain the thing that you fetched, that's maintained by somebody else that's maybe working in the same area as you, but and helps you to not end up duplicating effort and building something separate. So it's also, it also enables, and this maybe comes down to some of the questions around, responsibility. It also enables you, if you want to take entire responsibility for everything end to end, it enables you to take the value from the content and essentially cache it in to the ultimate extent in your local environment and still make use of it. So we're pretty much running up to the time we want to finish before questions. So I just wanted to give you a few references for more information. So all the things that we've been looking at in terms of the APIs and the artifacts, they're all very well described in the FHIR terminology module documentation. Again, don't get scared by FHIR if you don't use FHIR. It's just a good set of APIs for representing a terminology model. There's also a bunch of other useful information. We'll share these slides out so you can use it. There's a YouTube video that's done by a colleague from CSIRO that's really good. It basically explains in a very basic level the concepts of FHIR terminology, all in a storyline of the Wizard of Oz. So you've got, you've got a tin men and things like that, and describe things in a context that makes it really easy to understand. We've got obviously the landing page that takes you to all the NHS England servers. There's a bunch of information about the service as a whole. There's training guides, there's quick start guides for developers, for beginners. There's also GitHub repositories with, I think, hundreds, if not thousands, of API examples of how to do different things. And then there's also another GitHub that contains some information about how you do things like hook up Power BI to the terminology server and that kind of thing. And I think that's pretty much it. I would encourage you to take the bait a little bit and see if we can, rather than try and build all the fancy stuff first, in terms of doing magic AI things. I'm not against AI. I think it's brilliant. It's got lots of potential. But essentially, we need to be careful that we put the effort into the foundations that enable AI and computers to help us solve the problem, rather than just bury our head in the sand and think we can just do shiny stuff and not even consider the fundamental rate limiting factor and the fundamental foundations of doing anything with data is to get the quality and meaning of your data well described and completely understood. I think that's it from me. Back to you, David.
Oh, yeah, thanks a lot, Dougal, and thanks a lot, Steve, for the demo. I'm just looking at the questions, and I think that many of the questions are observations, or they are, yeah. I don't think there's anything that needs to be answered there, which is really, really good. I would just
I just noticed Mark's question at the end. Yes, the same service is in Wales. So at the moment, Scotland and NHS England have Onto server, a FHIR terminology server. Wales also has a FHIR terminology server. It's also Onto server, and it's also syndicates its content from the NHS England server. So it should be something you can use as a consistent approach across the different nations. I would also say that it's not just England and Scotland. We're also involved worldwide doing other implementations. So the same technology is used in Australia. The same technology is due to go live in Canada in the next couple of weeks. It's also the same in the Netherlands, and you'll find, particularly around the European health data spaces area, that there is a huge amount of work going into trying to standardize the way that terminology is managed and accessed. And as I said, if you're not FHIR, ignore that. Everybody is using the FHIR terminology model to represent that.
Okay. Yeah, Mark just had a follow-up. What about Canada? Are
Yeah,
they?
so Canada, we have only started about 6 weeks ago in terms of the implementation. It's due to go live in 2 weeks or 2.5 weeks.
Okay.
But if you've got specific needs, please get in touch, because we'd really love to get you involved in the rollout.
Okay. Well, thanks again. This this Zoom presentation will be uploaded on the INTEROPen YouTube channel. So for those of your colleagues who weren't able to make this, they will be able to also look at this this whole recording. Just a quick plug. Upcoming events. We're trying to organize a hack around terminology server. If we're lucky, it could be towards the end of June. We will keep everybody informed about that. We would like to do that in person. So we will keep you informed when we can do that. And we're also going to do something around in social care, where they've got the minimum operational data set, which is an important set of data which every social care application needs to be able to store. So we want to be able to do a learnathon kind of around that, followed by a hack where we'll look at social care systems in particular being able to exchange that data for using FHIR. So those are the next set of events that we are looking to do. We would welcome any suggestions that people have got for what we think would be very good events to run in the area of interoperability. So if you do, by all means, come back to me, or go through our website, which is interopen.co.uk. So with that, I'd like to thank Dougal and Steve again. I'd like to thank everybody who's attended for attending it and sticking around to the end. I'm sure you thought it was all really, really worthwhile. Thank you very much again, and I hope that we'll see you all again soon. So thank you very much.
Thanks, bye.